Everyone looking at class number 51, we're going to use the impulse momentum theorem to predict stopping times, velocities, forces, all that good stuff. So just a reminder, here's the impulse momentum theorem. And all three of these equations can be pulled from the impulse momentum theorem. Another equation that we have to make sure we have on hand for today is our momentum equation. Momentum equals mass times velocity. All right, so let's get going. All the answers are here. We're just going to go through the work. So a cannonball with a mass of 1 kilogram is fired horizontally at 500 from a 500 kilogram cannon, which is initially at rest on a horizontal surface. The cannonball is acted on by an average force of 8,000 newtons for 0.1 seconds. What is the magnitude of the change in momentum of the cannonball during firing? So we're looking for delta P. That is our unknown. Okay, so let's think about how we can find delta P. All right. So, well, let's see what else we have. We have some masses. Mass of the cannonball, which is 1 kilogram. And we have the mass of the cannon, which is 500 kilograms. We also have the force, which is not 5,000, but 8,000 newtons. We have the time that the cannonball is acted on, which is 0.1 seconds. All right, so I think we can use the equation F times T equals delta P. We're just looking for delta P. So we have 8,000 newtons times 0.1 seconds equals delta P. That comes out to be 800 newtons times seconds. All right. Now let's look at the next one here. So we have a 1,500 kilogram car, so that's the mass, 1,500 kilograms. And it's initially moving at 20 meters per second, VI. It is brought to rest, so its final velocity is 0, by a constant force in 4 seconds. What's the force? So I think this one we're going to use Ft equals delta P. Now if you're saying, well, what do you mean delta P? Well, look at this. So F times T equals P final minus P initial. F times T equals M V final minus M V initial. So let's see, we have F is our unknown. T is going to be 4 seconds. I'm going to substitute with units just to get in those good habits. Equals, let's see, now we have 1,500 kilograms times 0 meters per second minus 1,500 kilograms times 20 meters per second. Working through the math here, we have F times 4 equals, let's see, this is 0, minus, and I think this comes out to be 30,000. Divide both sides by 4, you get F equals negative 7,500 newtons. Now that negative should make sense because it's a stopping force. It's opposing motion. So why did I put the positive on the answer line here? Because we were looking for the magnitudes. They just care about the number. They don't care about the negative. The negative won't be wrong, but just do realize that they're just looking for the number there. All right, so we have a 2,200 kilogram car, and it's traveling at 10 meters per second. That's V initial. And the brakes can apply a force of 5,000 newtons. Now it's important to note that that's going to be a negative force because it's stopping the car. If we made this a positive force, it would speed up the car. And we get a V final of 0 because it's stopping. And T is our unknown. So we're basically going to do the same thing as before. Ft equals delta P. Ft equals mv final minus mv initial. Okay, right? P final minus P initial. And we'll start plugging some stuff in. So we have negative 5,000 newtons times T equals 2,200 kilograms times 0 meters per second minus 2,200 kilograms times 10 meters per second. So on the left-hand side here, we get negative 5,000 T equals, this is 0 here, and this is going to be minus 22,000 divide both sides by 5,000, negative 5,000, and you get t equals 4.4 seconds. If you had gotten a negative time here, you should have realized there was a mistake. What was the mistake? That you did not make the force negative. So if the car were traveling at 20 meters per second instead, so it's the same car, so the mass is still 2,200 kilograms, and the initial velocity in this case would be 20 meters per second instead of 10. Okay, you're still stopping it. How much force would be needed to apply to stop it in the same amount of time, 4.4 seconds? All right, so let's work through it. Ft equals delta P. Ft equals mv final minus mv initial. All right, I'm not going to substitute with units because I already have the units over here on the left. So we have F times 4.4, 2,200, 0, minus 2,200 times 20. Work through the math here. You have 4.4F equals, this is 0, this is minus 44,000. Divide both sides by 4.4, you get F equals negative 10,000 newtons. Or if you got 10,000, that's fine too. Notice V final isn't always going to be 0 here, but in these cases it is because we're talking about stopping. Okay? If you're talking about starting, then the V initial would be 0. So this question was a little bit ambiguous. There's two ways to look at it. I didn't tell you if the 10 newtons was speeding up the stroller or slowing it down, so we'll go at it both ways. So the mass of the stroller is 25 kilograms, that's about 55 pounds, and it's traveling with an initial velocity of 2 meters per second. So the force we don't know. Let's say it could be positive 10 newtons or it can be negative 10 newtons. I was ambiguous accidentally. Doesn't really matter which one you pick as long as you do the work correctly. And the time is going to be 2 seconds. What's the final velocity of the stroller? So again, two ways to do it. Let's do it the first way here. Ft equals delta P. Ft equals mv final minus mv initial. All right, so working through this here, let's do positive first. We have 10. I don't need the units because I put them in the givens. 2, 25. V final is my unknown. V initial is going to be 2. So let's see, we have 20 here. 25 V final minus 50. All right, so now I'm going to add 50 to both sides. So I got 70 equals 25 V final. And we should get about 2.8 meters per second is the final velocity. That makes sense because it's a positive force, it's speeding it up. Now, if I did it the other way, I'm just going to do it a little bit differently. I would have had negative 10 times 2 equals 25 V final minus 25 times 2. Now this force is going to be slowing it down. So we get negative 20 equals 25 V final minus 50. This comes out to be 30 equals 25 V final. V final comes out to be 1.2 meters per second. How long you need to apply this force to stop the stroller? Okay, so now if it's stopping it, we know that the force is going to be negative 10 newtons. Just write down the givens again. This is 25 kilograms. We know the initial velocity is going to be 2 meters per second. And we know that the final velocity, if it's stopping, is going to be 0 meters per second. So Ft equals delta P. Is going to be negative 10 T I gotta fix that up. 25, 0, 25, 2, negative 10 T equals negative 50, and T ends up being 5 seconds. So it takes 5 seconds to stop. So we have a 60 kilogram woman wearing a seatbelt. That's about 132 pounds. in the car is traveling, or excuse me, in a car that is traveling with a velocity of 10 meters per second, car is brought to a stop in zero point 0.5 seconds. What force did the seatbelt need to exert? And we get negative 1200 newtons. That should make sense that it's negative because it's a stopping force. If I ask for the magnitude, you could write 1200, but negative does make sense because the force is opposing motion. If the car were moving faster, how would this force change? Two ways to do it. Use common sense. Well, if it's moving faster and you still want to stop it in the same amount of time, you need to apply more force. Or just plug in numbers. Plug in instead of 10, plug in 20 for the initial velocity. You'll get a bigger number. Now, last but not least, I forgot to give you the mass of a golf ball here. I think I told every group a slightly different number, but I think the mass of a golf ball is about 45 or 46 grams. I don't really care which one you use. Your numbers will be slightly different if you use the other one. Um, just use a nice round number. I'm going to say that the mass is equal to 0.045 kilograms. That's 45 grams. All right. So we know the mass of the golf ball. Let's see, a force of 5,000 newtons. So I don't think that's a realistic force, but it's all right. It's just a problem. Let's see, stationary. So the initial velocity is going to be 0. The final velocity is going to be 35 meters per second. What is the magnitude of the impulse? Okay, so again, impulse is change in momentum or force times time. So looking for J. Well, I can't use force times time because I don't know the time, but what I can do is I can use change in momentum. So I don't have to plug in the units because I wrote them down in the givens. And the impulse is about 1.575 kilograms times meters per second. So how long was it in contact for? So we're looking for T. Well, now I can use the equation J equals force times time because I know the impulse now and I know the force. So the impulse is 1.575. I don't need the units because they're already written above. The force is 5,000 and time is my unknown. Time ends up being a very small number, 0.0000315 seconds. There you have it.